Welcome everyone. We are organizing these seminars to introduce the data science and analytics program. This is the first seminar. So what we are trying to do is we are inviting people from different backgrounds, different disciplines, because the data science and analytics program is an interdisciplinary program. Today, Mert Moral, he's an assistant professor in political science program at Sabancı University. He's going to present his paper about the effect of earthquake on voting behavior. Hocam, thank you very much for accepting my invitation.
Hocam, thank you very much. So I am a faculty member here at Sabancı University in the Political Science and International Relations program. Unfortunately, we have a scheduling conflict with our program, and many of my colleagues and our students actually could not attend because they decided to attend the economics seminar. I mean, that's we are actually having. So we had an invited guest speaker from Bilkent University, if I'm not mistaken. So today I'm going to present a paper which is co-authored with Onur Hoca from FENS, with Serkan Hoca from FAS, as well as two of our colleagues, one from HSE, Russia, the other is currently at Bilkent University. So it is a multidisciplinary project. It is basically also an inter-faculty sort of collaboration between FAS and FENS, in the sense that I would say since the devastating earthquakes in February 2023, we have been trying to actually gather data in order to causally identify the effect of the earthquakes on electoral behavior in the May 2023 elections. So let me explain why we are interested in this phenomenon. You will remember that it's sad to talk about that, and I do agree. I mean, this is not a motivation frame. There were two huge earthquakes that took place at like 4 a.m. and at like 1 p.m. On the same day, on February 6, 2023. With their aftershocks, some of them reaching to 6.7 and 6.3. The earthquakes caused a total of almost 51,000 Turkish citizens, about 6,600 foreign citizens, and about 1,000 unidentified deaths. In addition to more than 107,000 injured people, according to the official records. So the initial estimates, given the magnitude of the earthquakes, were more than 130,000 casualties and twice as many injuries. So by looking at the official numbers, right, I mean, we may simply conclude that we were lucky. On the other hand, the reports, the unofficial reports, the anecdotes coming from the region suggest otherwise, right? And well before, the public has started to accuse Recep Tayyip Erdogan government of underreporting deaths and injuries, its unpreparedness, its lack of organization, low state capacity in general in Turkey or in the region, and late, if any, evacuation and relief efforts. Those numbers were basically released to the public and started to be questioned. So after the earthquakes, it is estimated that 3.3 million people actually had to evacuate the region, either temporarily or permanently. As of February 24th, that is like 18 days after the earthquake, roughly 1.2 million people were living in temporary welcome centers in 71 provinces, except for one. All of them were out of the region. Anadolu Agency, the official news agency of the Turkish state, later updated this number as 1.3 million. That is about like a week after the initial estimates. Another peculiarity about this date, March 3, was that it was 2 weeks before the end of the registration period for the upcoming elections on May 14th. Supreme Election Council, Yüksek Seçim Kurulu, allowed affected regions, voters from the affected regions, those 11 firstly, then 15 provinces, to update their registration records, their election registers, between March 20 and April 2. Despite this extended period, however, only 133 out of 3.3 million people actually registered elsewhere than the region. So the cost of the earthquakes was huge, as you would expect. According to World Bank, based on the spatial population registration system, adresi dayalı nüfus kayıt sistemi, there were 2.6 million buildings in the region. In the 11 most affected provinces, and here is the list of them. Also, according to the World Bank, 105,000 of them, that is like about 4%, and 384,000 independent sections, these are simply apartments, were heavily damaged, to be demolished as soon as possible. These are about to be collapsed, partially collapsed or collapsed. So this is as of February 19. This is basically 2 weeks after the earthquake. There were no official updates whatsoever after April 21st about the number of wrecked, heavily, moderately, slightly damaged or other buildings in the region. We also have no data at the neighborhood level or at the district level. And we don't have more detailed, less aggregated numbers about specific categories. So they only released the total number of buildings that were either to be demolished or demolished. But as you would expect, right, I mean, there is a huge difference between a demolished building and a slightly damaged or moderately damaged building in terms of the casualties and the injured. So given the hype about, and mostly the high level of competitiveness that we are not used to of the May 2023 presidential elections, unfortunately few, including ourselves, right, have continued to ask about the actual human and financial costs of the earthquakes. So our research question is motivated mainly by this, I'll say, statistic, aggregate statistic, that I'm pretty sure you faced, right? I mean, in almost all, conventional and social news media outlets, right? It simply says that in the earthquake region, right, Cumhur İttifakı, the incumbent alliance of the AKP and MHP, as well as some other minor parties, actually had an electoral victory. And the turnout, even in Hatay, right, one of the most devastated, if not the most devastated cities, was higher than 80%. Remember, there were 3.3 million people, roughly 2 months before the elections, who actually had to move out of the region either temporarily or permanently. So our research question is, let me remind you why I put that perfect storm in quotation marks. Let me remind you about the economic situation, right? I mean, macroeconomic situation in Turkey, increase in inflation, increase in unemployment, decrease in purchasing power parity, in addition to the lack of, relief and evacuation attempts in the region, right? And according to the official statistics, we are talking about more than 50,000 deaths. And despite all these circumstances, right, that a professor from Koç University accurately described as a perfect storm, like that movie in Twister, right? AKP and the incumbent president Recep Tayyip Erdoğan seems to have gained some electoral support, maintained the turnout rate, right, and basically got even higher electoral support in some parts of the earthquake region. In this study, we simply ask, how did the February 6th earthquakes actually affect turnout and electoral behavior in the May 2023 presidential and parliamentary elections in Turkey? So, I am one of the co-principal investigators of the Turkish election study, which is sponsored by Sabancı and Koç Universities. And in Turkey, there are 26 statistical regions. Okay, these are called NUTS. These are basically groups of provinces according to their contiguity, right? I mean, whether they are next to each other and according to their populations. In one of those NUTS2 regions, statistical units, we actually could not conduct any survey interviews. That includes Hatay, Osmaniye, and Gaza. Why? Simply because there were no restaurants for the interviewers to dine, right? There were no hotels for the interviewers to actually stay overnight. And basically the addresses that we get from the Turkish Statistical Institute, the official addresses, I mean, they were not there. Most of those buildings were either vacated or demolished. So we actually had to exclude one of those 26 administrative units. I'm sorry, statistical units, and conduct our survey interviews in the remaining 78 provinces. So it was not possible to conduct face-to-face interviews in the region as of August 2023. But we are talking about May 2023. Okay, 3 months before we couldn't even conduct interviews. So there is no available individual level data that comes from the region. We could simply, conduct a survey experiment or maybe a simple survey study, right? And ask individuals what motivated you to vote such and such way, right? But we couldn't do that. So we actually had to resort to the second best option, which is basically collect whatever data that we could have our hands on. As usual, in Turkey, official data are quite scarce. We don't have any data at the building level, at the street level, at the neighborhood level, or even district level that is available to the public, to the researchers, right? So we could basically understand how the earthquakes affected electoral outcomes. So we simply try to estimate the causal effect of the earthquakes on two things. The first is the shares of those who voted for particular candidates and parties. These are the party and candidate vote shares. Over two things, the reported eligible number of voters and the ones that we predict. Okay? Because some of those individuals, I will explain that in a minute, actually were unfortunately lost, right? But were not dropped from the registers. And we will try to do that at the lowest level of aggregation for which we could find data, that is the neighborhood or village level. So let me get to the data part. I hope this is the one that's going to interest you more. The seismic magnitude of an earthquake is constant, right? I talked about 11 provinces that were affected. And all those were hit by the same magnitude. That is 7.8, for instance, right? But the felt intensity is measured differently, and felt intensity varies from region to another. So there is a modified Mercalli intensity score that is widely used by the experts, and there are roughly 10 categories there, 11 if I'm not mistaken. And here I explain what the scale from 6 to 10 actually means. Okay, 6 is strong. It is a slight damage. Everybody feels that, right? 8 is severe. It is basically considerable damage in ordinary buildings with partial collapse and great damage in poorly built structures. That is like most of the Turkey's building stock, right? 9 is violent. It means great damage and partial collapse even in substantial buildings. Liquefaction of the earth. That is basically the buildings disappear within the earth. And shifting of the foundations of all buildings. And 10 refers to extreme intensity, corresponding to huge landslides, bent railroads, destruction of even well-built wooden structures, not even the other ones, substantial ones. And most masonry and frame structures are also demolished. Now I'm going to show you a graph. Here, this red line actually shows intensity that is between 9 and 9.5. Let me try to zoom here. And you could see some parts on that line actually show intensity that is 10. Okay? That's a disaster. And how did we actually get this intensity measure? There's the data part, okay? These are basically interpolated, okay? There are like multiple sensors in the region, if I'm not mistaken, 113 of them, okay? So the experts in the United States Geological Seismological Institute, USGS. They actually triangulate all those sensors and try to actually find the intensity at every particular region, okay, depending on the their level of granular data. What we did after we actually got those data, we overlaid a map of neighborhoods in Turkey and calculated the weighted averages of the felt intensity for every single neighborhood of 9,000 neighborhoods in those 11 provinces. Okay? And this is only for the initial earthquake that took place at 417. And afterwards, there was a second earthquake, as you would remember, that actually hit a different part. You see, Hatay, for instance, is not affected as much in the second earthquake. So if I were to focus on the region, remember there were two huge additional earthquakes, 6.7 and 6.5. And if you actually take a look at the maximum felt intensity in either one of those four huge earthquakes, you see a 7-like shade there that shows somewhere between 8.5 to 9.5 intensity. Again, this is a disaster. Okay. I remember these are coming from seismic surveys, right? And then this is interpolated data. Another way of measuring that is relying on satellite images. So there are certain satellites, some of them are used by NASA, right? They actually take photos of the Earth every time they pass over a certain region. And by geolocating certain structures, right, that they use for referencing purposes, they can then compare those images and figure out whether the area, the Earth, actually was displaced, as a result of the earthquakes. And they found in some parts, you see here with the darker shades, basically the Earth was displaced up to 2 meters. Okay? There was anecdotal evidence that simply suggests that there was, for instance, an olive tree that moved by 11 meters, okay? But on average, those neighborhoods moved by 2 meters. So these are different measures these are different proxies for measuring the intensity of the earthquake that actually hit different parts of the region at varied levels. Of course, there were some rescue attempts, right? Government tried to respond to all the demands coming from the region, but there were some parts, for whatever reason, right? I remember I told you if the felt intensity is close to 10, even the railroads are bent, right? Remember the Hatay airport actually was not functional after the earthquake. Certain ports, including Iskenderun port, were not accessible. So rescue attempts actually were not very successful in reaching the affected region, right? So these data come from afetharita.com, which rely on Twitter posts and their retweets. So you see different shades here. Those shades actually show, again, how many tweets with photos coming from the region, okay? And the bars here, basically, the tallest bar, all the bars are should be the same height, yes. So a full bar like this actually shows a 48-hour period after the initial tweet, okay? And within that 48 hours, I actually tried to follow, right, whether another tweet coming from the region, retweeting the original one, or simply were posted from the same location, okay, mentioned the same building. So if the retweets were, stop at a certain point, I simply assume that basically rescue attempts arrived, right? The officials actually arrived there and started the rescue attempts. But in certain parts, you see, especially in Hatay, for instance, right, the bars are full, which means the help actually arrived there almost like 2 days after the initial tweet, okay? In some other parts, for instance, close to Iskenderun port, we see that actually the state was there. They got there on time, right, and tried to rescue those who were, under the rubbish, right? So that would allow us, I mean, there were not, of course, as many tweets as, you know, as fine-grained data like this, but I mean, this actually shows us that not every single region was affected the same way, okay? And the grievances were simply not the same, probably because state actually did help certain parts and could not, or maybe did not, the others, okay? Another alternative is relying on nighttime lights. Again, same satellites, I mean, fly over, you know, certain regions, and they take photos, nighttime photos of illumination on the ground. So when you overlay this neighborhood level data, okay, you can simply calculate the socioeconomic development in a given neighborhood by looking at the nighttime luminosity. Because, I mean, if there are like big avenues, right, I mean, roads, I mean, those are, I mean, if close to the city center, due to the level of urbanization, right, I mean, those are illuminated better than the rural parts of the country, for instance. And if there's a socioeconomic development over time, you see the illumination increasing over time. So this shows the long-term change in nighttime lights, basically the difference between a month after and 11 months before the earthquakes, okay? So if there was a total collapse, as in this region, for instance, okay, and it wasn't restored a month after the earthquakes, then you see a huge change. But this doesn't necessarily correspond with the 7 figure that I showed you, but here, in this part, we actually see a huge loss in terms of the socioeconomic activity, okay? Economic activity, my apologies. Of course, Hocam, go ahead.
Well, like, the color, red color and ones to which
Yes, red color means almost 100% of the initial, I mean, from 100 to 17% of the initial measures actually decreased in a year. Was gone. Green, I mean, these greens actually show about like a 30%, up to 30% increase, no, up to 300% increase. This shade, for instance, shows somewhere between 15 to 30% increase. So for some reason, for instance, if there is a center for the earthquake, you know, survivors, right, that was built in the middle of nowhere rural parts, right, they actually built a new accommodation center there, and then hence the positive change. But I mean, these are very scattered, as you can see, and mostly in the rural parts. Of course, I mean, I did not mention it as explicitly, but I mean, everybody that I could talk to, I mean, were almost always, right, I mean, suspicious about something that could lead to these observed outcomes, right? It is electoral fraud. Of course, we are not accusing anybody of doing electoral fraud, right? But we are concerned about that. So we basically try to measure. And how could we measure? There comes, again, this, you know, one of the, I'll say, clever ways of collecting data. What we did is we basically went over the vote and beyond, oy ve ötesi records, okay? So oy ve ötesi observers and some party observers, what they do is that they actually upload photos of the ballot box reports, right? And basically what we did is we know all the ballot boxes from the region, and we matched them with the related report photo, right? If there was a photo, we simply coded that as 1. Then we aggregated those ballot box level data to neighborhood level data in order to show you the percentages of ballot boxes from a particular neighborhood with the presence of either independent or partisan election observance, okay? So the darkest green actually refers to almost 100% of ballot boxes in a particular neighborhood being observed. And this one, that is just white, right? And there are like almost 6,000 out of 9,000. There were no observants, either partisan or from vote and beyond, that were present, okay? So you may ask, okay, our election records, election registrars, as well as the Supreme Election Council, are quite good at collecting data, processing those data, right, and updating their records. You wouldn't believe that, but it's one of the best working institutions in Turkey in terms of publicly available data. They actually have certain grants as well as certain awards coming from European institutions about the openness and transparency of their acts. I'm talking about the Supreme Election Council, not the Turkish Statistical Institute, okay? And they may have updated their records. And we have anecdotal evidence about like particular village heads that simply say, okay, Supreme Election Council got in touch with us. We actually informed them about how many people were lost. But when we look at the eligible voter counts, whether they updated, we don't see any pattern that actually resembles that 7, okay? And it's not correlated at all. So it's not, I mean, those updated eligible voter counts, the increases, do not come from, for instance, the urban centers, do not come from district centers, do not come from the regions with more, I'll say, heavily damaged buildings, okay? They are scattered all over the region. And this also applies to turnout. Turnout did not increase in particular regions, okay? It is not, basically, it doesn't follow that pattern of the earthquake intensity that we actually show. So the million-dollar question is how to predict the real human and financial costs. You don't see those numbers, but let me read them to you. We basically coded data from the Çevre ve Şehircilik Bakanlığı, Ministry of the Environment and Urbanization, I guess, planning. So what they did is they actually sent groups of 7 experts to every single building in the region, 2.6 million buildings. Okay, there were architects, there were construction engineers, there were civil engineers, there were other sorts of experts, health experts, and all those people went and visited all the buildings in the region and took photos and evaluated the status of those buildings after the earthquake. Okay, there were certain categories, remember, no damage, slight damage, moderate damage, high damage, partially collapsed, fully collapsed, to be demolished as soon as possible. And they actually release those data, okay, to the affected on the website. And every single person with a Turkish identity number, okay, could basically select their own street, their own neighborhood, their own district, their own province, and see the status of their own building, okay? And if the report is not in their best interest, or if they think otherwise, right, they may simply, ask for another evaluation. And after a certain period, I would say 15 days, if I'm not mistaken, they re-evaluate that, and then the final decision is posted to that website. We downloaded those data 4 times, okay? Literally like 19 days after the the quakes, about like 35 days, about 50 days, and lastly in November 2023, okay? Because this is the last version of the data. Remember, those data are at the building level. We then aggregated them to the neighborhood level and calculated the shares of the wrecked buildings where people may have lost their lives, okay? From heavily damaged to fully collapsed. And this graph shows you the change in the share of heavily damaged to be wrecked or demolished buildings over all buildings that are surveyed in the region. Take a look at Malatya, for instance. If we were to stop data collection at this point, right, we would have simply concluded that, okay, there were a lot of demolished buildings in Malatya. But the more they surveyed, basically the share has decreased. In other parts, it was more or less constant. In some others, like Elazığ, it increased. This basically suggests that, most of those wrecked buildings in Elazığ, for instance, come from rural parts of them, okay? Because the rural parts were surveyed later. So at the end, we basically have data at the building levels of roughly 90% of all the buildings in the region. Okay? About 2.6 million entries, rows of data. In order to estimate the effect of the earthquakes on electoral behavior, what we need to do is first we need to determine certain things, right? But the issue is we just see the counts. The reports, the ballot box reports, do not tell us how many people moved out of the region, how many people were lost. Remember, there were no official data. So there are certain categories that we need to either predict or simply assume that they do exist or do not exist. For instance, there are people who moved away permanently and registered elsewhere. We know that their count was 133,000, but we don't know where those people are registered to, where they moved from, exactly what neighborhood, and which neighborhood did they move to. We employ the neighborhood levels population-based address registration system data, and those data actually provide us with a way to predict that. Why? Because we know where people's, I'll say, ancestors were actually born in, right? They're kütük. And we know that at the neighborhood level. So we can simply look at the population trends and calculate their relationship with the eligible voter trends in order to figure out the average age or average aging trend of particular neighborhoods, right? And depending on what percentage of people living in that particular neighborhood are registered or their ancestors to the earthquake region, we may simply calculate, right, the within neighborhoods moving patterns. Okay, so we would expect people being from the affected region moving to neighborhoods where people like them or people they know, they used to know, actually tend to live, right? But that is based on predictions, that is based on probabilistic associations. People who moved away permanently could not change their registration records, but they did or did not turn out. That's a huge problem. Remember, there were 3.3 million people 2 months before the election who were living in other provinces. So what we do is that we simply assume that between the May 2023 and March 2024, right, the local elections, YSK, Supreme Election Council, could manage to update the election registers. Okay, so these people are now registered to their new places. So by comparing the previous and most recent election outcomes, we can actually predict their counts. We don't know the exact number, but we will try to predict that. I mean, that's as best as we could get. This is the Supreme Election Council's official report. They simply announced the aggregate number. They didn't explain where that number comes from which provinces, which districts. But we do have population records, official population records from 2023, 2022, and 2024. And we also know where those people are registered to, right? I mean, they're kütük, so we can basically try to compare those changes. People who moved away permanently, but still registered in the region, and they commuted to vote. Remember all those buses, all those planes going full, right, and coming back full to Istanbul, to Ankara, to Izmir. The issue is that most of those people were basically very frustrated and did not commute in the second round. So by comparing the turnout in the first and second round, we basically have a very rough estimate, very rough approximation of who did commute and who did not. There were people who passed away and were dropped from the list of eligible voters. Very small, but there were some. There were people who passed away and were not dropped from the register. That's the main problem. Okay, so those two we try to predict using the felt intensity, using the share of the wrecked buildings and stuff. So fraud, if any, could be measured by predicting the share of ineligible eligibles. Okay, those who look like eligible but actually ineligible. We also adjust for the share of ballot boxes with independent observers. I will show you some conditional treatment effects, average treatment effects that simply show a quite weird pattern of an U-shaped pattern. I will try to make sense out of that when it comes to that slide. So all in all, this requires employing data from multiple sources with varied availability, reliability, temporal and spatial coverage. Hence the 5 people team. I mean, coming from computer science, data science, social sciences, and communication. Okay. And then you may ask why the communication person is there. He is a political scientist by training, and he is an expert of electoral fraud. Okay. So our data sources are those. We have the ADN-KS, population-based address registration system data at the neighborhood level, covering the last 10 years. We have official election data that also covers the last 10 years. Then we can calculate their respective trends for particular neighborhoods and villages. We have nighttime lights data to approximate neighborhood level socioeconomic status or district level socioeconomic status. We can disaggregate or aggregate that or impute that, and we had to do it for certain parts, especially the new neighborhoods that were founded after like 2023, for instance. We actually had to rely to where they were separated from. We also have neighborhood level sociodemographic data, education, gender composition, income, and such. We also have several geocoded control variables, distance to district center, for instance, about the development of particular neighborhoods, independent units to buildings ratio in order to measure urbanization, because I mean, think of taller buildings with like more independent units, more apartments that simply show a higher urbanization rate than villages. Household size that basically gives us whether it's a conservative part of the country or not, right? I mean, how many small families are there or large conservative families are there. And we also have some other demographic data, as well as various other sorts of data, like the number of mosques, number of hospitals, ATMs, pharmacies, you name it. Okay. So what do we do? Basically, because the intensity varies, right? The treatment is heterogeneous. So not every single neighborhood was affected the same way. Okay? Some were affected like on the intensity scale up to like 10 units. The others were up to like 6 units. So what we do is, instead of using a continuous treatment, we discretize it. We created 4 categories, okay? Highest intensity, high intensity, mid-high intensity, mid-intensity. We did that based on the intensity and the share of the wrecked buildings. Then, what we did is, we basically matched the neighborhoods, okay? Say, with the heaviest felt intensity, to neighborhoods outside of the region, based on their previous electoral records. Okay, so here's an example. Think of Hatay, for instance, right? Hatay is a region where basically most of the people are either Alevis or half of them are CHP voters, right? Now consider a particular neighborhood from Hatay that is to be matched with another neighborhood. Of course, it's not one-to-one matching, but probabilistic matching, right? What we are using here is called an entropy balancing or a quotient exact matching algorithm. So we do both one-to-one matching and probabilistic matching. We are trying to find another neighborhood that is very close to that particular Alevi populated neighborhood in Hatay. Okay? In terms of its socioeconomic development, in terms of its ethnicity, and how do we measure that? By looking at the previous election records. Okay. So we basically use the nighttime lights data, main opposition parties' vote shares coming from the pre-treatment period before the earthquakes. We use the support for the incumbent party, AKP, and support for the incumbent president, Erdogan. And we use population density, we use district level socioeconomic status, and we try to match those neighborhoods that were heavily affected by the earthquake to those that were not affected at all. We then compare the treatment and the control groups as if like a controlled experiment, okay? And try to find out whether being exposed to the treatment, being exposed to the earthquake, and being in that category, say the heavily affected, affects the electoral outcomes in such and such way. Then we estimate different diff models on the change in voter turnout and electoral support for the incumbent party and candidate between the May 2023 elections and the most recent presidential and parliamentary elections in June 2018. So In short, these analyses allow us to predict the decrease in turnout, and as conditionally on that, the change in electoral support for particular parties and candidates vis-a-vis the matched or control group at the neighborhood or village level. Yes, hocam. Go ahead. No, these do not account for the spatial heterogeneity, because the weighting matrix comes from the the matching itself, so it needs to be multiplied with the spatial matrix, which is like a squared sort of matrix, which we don't actually even attempt to. That we accounted for. The analysis include province level and district level fixed effects. In addition to that, by looking at what percentage of the population living in particular neighborhoods actually come from or are registered to the affected regions, we basically got rid of like almost 10,000 neighborhoods where the population share of those people coming from those 11 provinces are higher than 25% of total population. Okay. So that we try to account for, but this is like a robustness check. Well, we didn't account for the spatial heterogeneity. So these are the average treatment effects of the earthquake. Okay, these come from separate models based on two of our measures, either the intensity measure that I showed you or the share of REC data that we actually coded from the official data. And this category is the lowest damage or lowest intensity category. In the lowest damage, we are talking about 1,200 neighborhoods. In the lowest intensity, we are talking about roughly 3,000 neighborhoods. Okay, this is the low damage, high damage, and highest damage. So the highest intensity refers to something above 9.5. Okay, these are totally demolished parts. But highest damage does not refer to that. Highest damage is roughly like 1/4 of all the affected neighborhoods. So hence the differences in the effect sizes. Okay, here you see basically the change in water turnout for parts of the region that actually experience some damage, okay, but not too much. You see that turnout actually increased by 1 to 1.5%. Okay. In the parts of the region, either in those 250 neighborhoods that should have been demolished altogether, right? Or in the 1/4 of all ones, you see that turnout either did not change, okay, the predicted change is 0, or it decreased by about like 5 points. So if you follow those red lines, you see a nonlinear effect, okay, as conditioned by the increase in intensity, felt intensity of the earthquake. But if you actually compare the black dots, you see that there is not much of any effect that comes from the share of wrecked buildings. So this is kind of weird in the sense that, if you feel the earthquake, right, turnout decreases. But if you actually look at the share of wrecked buildings, we actually do not find a negative effect. Okay, so we are shocked by that, but this mostly comes from the number of neighborhoods in those categories. So if you try to actually discretize that by creating like 6 categories, then we observe that nonlinear effect, and with where the average treatment effect actually becomes negative. Okay, yes, hocam, go ahead, please.
The drop is 5%,
Yeah,
right?
roughly 6%.
Compared to the 2018 election.
Yes.
So, and for the...
Not compared to the, yes, compared to the 2018 election, but here, remember, this is the treatment effect that comes from the difference between the treated and the control groups. Okay, so the change in the treated minus the change in the control.
And for the data on the building, effect on the building, wrecked, demolished, etc. So you said that over time, some numbers changed.
Yes.
People challenged the first reports, evaluations, etc. And just a guess, could it be that people tried to change their building report from Do you know highly damaged to not so highly damaged? Like, do we know?
They did, but so heavily damaged to moderately or slightly damaged that
So
actually
that
have
they can-
important repercussions for how much state support that you are going to get.
Yeah.
But these actually take into account the wrecked buildings. So if the building is wrecked, I wouldn't expect that. But I mean, that we can actually account for. I mean, we have all those, percentages. We also already calculate that from like earlier releases of the data. So that we may account for.
So one last comment or question then. So looking at this, I'm tempted to assume that the red dots are more reliable. Because one expects some drop, right?
It may be. I mean, but I mean, in such a paper, I mean, that we hope to write, right? I mean, we basically do not want to rely on a single indicator. I mean, satellite imagery has its own problems. This sort of, felt intensity relies mostly on imputed data and then triangulation methods. So these are also conditional on like the Earth type, right? I mean, what happens, below the Earth, like 12 kilometers below the Earth and everything. So we have another measure that I didn't show you that is basically closeness to the fault line, which basically shows a totally different picture, because some parts of the region that were totally demolished are very far away from the fault line, but their apparently Earth type is, allow those buildings, to be demolished. So basically, we are trying to use different proxies in order to figure out, what might be the true effect.
Okay, thank you.
Yes, Hocam.
Maybe one thing we didn't take into account is like at Malatya, the demolished building increased and then decreased. So could there be a chance some opportunistic people claim their building is nearly collapsed to get some funds from government to rebuild it?
Might be. I mean, we may drop Malatya and try to do that again. I'll take a note. That also goes to the robustness checks. I have no idea. I mean, so the data here, this is all I'm trying to highlight. I mean, data sources are various, right? Their reliability, generalizability, validity, and coverage, it also varies a lot. So because of that, what we are trying to do is that we are trying to get our hands on different source of data, okay, as much as possible. And we are trying basically all our models with like different sorts of variables coded from different data sets in order to figure out, where that effect comes from. Either the measurement or the coverage or basically what we would expect to find, right? The causal effect itself. So if you take a look at the turnout difference in presidential elections, remember these elections take place at the same time, right? So there's not much of any difference. So I'm skipping to the vote share. Here, this is the interesting part. Actually, remember that news story that I showed you, right? It simply says that Cumhur İttifakı actually increased its vote share, as well as Erdogan, right? Increased his vote share in the region. But this graph actually shows a different story. It simply shows that, yes, it did, but the parts of the region where it did increase a lot, up to like 2.5%, are the low intensity or low damage parts, okay? So people who were not as affected, whose buildings were not demolished, right? They actually voted for AKP and Erdogan. So there are two theoretical expectations in the literature, two very contradictory. I didn't explain that, on purpose. The reason is they are super contradictory and we don't know which one would hold. This is probably the first time that, our expectations are not driven by the theory because of exactly this reason. Because remember the Katrina storm, right? The expectation was that if the incumbent doesn't do a good job, right, in terms of responding to to those who are affected, right, to rescue them, to help them, then you would expect the affected to vote for the opposition. But after the Katrina storm, something happened. People actually voted for the Conservative Party, the Republicans. The expectations are twofold, right? A, you don't vote for the incumbent if they don't serve. B, you vote for the conservatives. So what happens if the incumbents are conservatives? That's the case here, right? So some people may have voted for AKP because they actually expect to get some benefit, or they were helped. Remember, the grievances were also varying regionally, right? Or they simply vote for the AKP because it is the conservative party, right? So, or maybe there is fraud, so we don't know. Okay, so that might also be the reason. But I mean, basically the theory tells us two different stories with two different, very contradictory outcomes, right? You would expect the opposition parties to gain support if the incumbent could not deliver or did not deliver. But on the other hand, the incumbent is conservative, and people who are affected by the quote-unquote act of God tend to vote conservative as well. So apparently people who were hit but were not killed did vote for the incumbent for whatever reason, maybe to get help, maybe to get like additional benefits, maybe believing in their previous records and thinking that, okay, these guys are capable of delivering. We know, we observed them having delivered in the past and that they would deliver again. But those living in the highest damage or highest intensity, their basically support has only increased by less than 1%, okay? And remember, this doesn't take into account the change in the eligibility, okay? If you look at Erdogan, it's kind of weird. So AKP and Erdogan's vote shares actually show a very different effect. So take a look at the highest damage part. Apparently, Erdogan's vote share increased there, but did not increase in the high damage part. Okay? But if you take a look at the high intensity, you see a quadratic sort of effect, I mean, as conditional on the felt intensity. And we did not understand why. So the next graph that I'm going to show you actually takes this black line and calculates the marginal effect as conditional on the share of ballot boxes with vote and beyond observers or partisan observers present. So remember, the average effect was about like 0.5% here, okay? A boost in affected neighborhoods compared to the control group outside of the region. And how does it actually vary depending on whether those affected neighborhoods actually had election observers present. So about like 60% of all our observations come from neighborhoods, okay, with no observance whatsoever. And the effect is very small there. It's less than 1%, okay, 0.3 or something. In other parts, it basically increases up to like 2%. And where observers are present, remember these are the urban city centers, okay, we actually see roughly 1% increase in Erdogan's vote share. So this graph is super intriguing, and we don't know why we actually observe that. So let me go back to where you see the observers, okay? So first of all, the observers were not present in all provinces at the same level, but more so in Hatay and Adana, for instance, okay? Because most of those observers are CHP partisans. Secondly, they are clustered more in urban centers than in rural parts, okay? So the effect that we find here might well come from either the socioeconomic or ethnic structure of those parts, but we do account for them. That's the problem. So when we are matching, we actually match based on socioeconomic indicators, previous votes, and development as well. So this is kind of weird, and we basically don't know what to do with that for now. So in order to cut it as short as possible, I'll stop here, and thank you very much for listening. No, not yet, hocam.
This is somewhat weird, and we don't know what to do with it. Isn't a good.
No, this is basically Onur Hoca even is seeing the last graph right now. So that conditioned effect on conditioned by the vote and beyond presence. That is both risky and also illuminating at the same time. So we don't know what to do with that. I mean, so we'll probably experiment more with like different models and try to actually figure it out. I mean, why that's the case. Either I told a really, convincing story, or it was too technical. I don't know what's the answer. Okay, I guess. Hocam, we don't know where they were that. Okay, we have a couple of proxies for that. First, the share of all those wrecked buildings, in addition to wrecked independent units. These are basically the apartments, right? We simply know the population density, so we can calculate how many people were or should have been below those demolished buildings. On the other hand, we don't know how many of them were rescued. We don't know how many of them were simply injured, not dead. So we just have a proxy for that. The second one is we simply can compare the eligible voters in May 2023 with March 2024 in order to find out how many people were actually dead or moved out of the region. But they are observationally equivalent, so we don't know how many people actually were dead at that particular neighborhood level. So the state doesn't share those data with us, with the researchers, not only with us. Yes, John, please.
So this reminded me of financial consequence. So do you know anyone, if anyone, any group did similar study to estimate the financial consequence? There were numbers like $50 to $100 billion, but those were mostly like guess.
Yılmaz made a presentation from Koç University, an economist, about that. But if I'm not mistaken, his predictions actually come from those World Bank data that I showed you, which are quite outdated and which do not show, separate subcategories, right? I mean, wrecked buildings, totally wrecked. And those data, unfortunately, do not distinguish between industrial facilities and houses or apartment buildings, for instance. So it just shows how many buildings, separate units, were basically demolished. So you need to take into account how many, I'll say, households / how many production facilities are in particular neighborhoods. I doubt anybody has those data at the neighborhood level. I do though. But yeah, I mean, it's very hard to actually predict that. I mean, without basically a collaboration with like a economist. I mean, now since this is going to be published on YouTube, I will just say that I mean, we are open to all those possibilities and opportunities. And Hocam, I'm also looking at you. Okay, I guess that's it. Thank you very much again.